All right, kids, we are starting into quadrilaterals here with this video. And this is going to look a little daunting at first, and I understand that, but I don't want you to freak out. So look at these different quadrilaterals here. Um, you're going to have to know all these properties. So it looks like a lot, right? And it is a lot. However, I want you to realize a lot of these things you already know. So don't be freaking out about it. You know, I think all you guys already know that both pairs of opposite sides of a parallelogram are parallel. I think you probably knew that, right? Um, you know, a rectangle. Did you know that all angles are right? Yeah, I kind of thought you did. You know, rhombus. All sides are congruent. Yeah, I think you knew that. Okay. So I bet you probably know half the stuff here already. My guess is what you don't know a lot of times is like how the diagonals relate to each other. You know, their length, are they perpendicular, and the opposite angles. So I would focus on those properties. I mean, you have to know it all, but focus on those properties. And you know what? Something I want you to realize: you can usually guess a lot of times too. Let's take a rectangle, for example. If you draw a very obvious rectangle, like don't draw a rectangle that looks almost like a square, you can determine a lot of things about the diagonals just by looking at them. Are these diagonals going to be congruent? Yeah, they certainly are. Okay. Are these diagonals perpendicular to each other? I mean, look at how they intersect. There's no way. They don't have to be perpendicular. No. Okay. Do the diagonals bisect each other? Yeah, they do. You can tell a lot of these things. Do they bisect the opposite angles? I hope you realize that they don't. This angle here looks a lot smaller than that angle there. If you even drew it more elongated, you know, you could tell. My point is, sometimes if you're unsure of yourself, you can just draw something out. Okay. But yes, you're going to need to spend some time with this and get comfortable with these properties. Again, a lot of them you do know for sure. All right. Um, so now what I want to do is let's go to the other document, and that is this one here. Whoops. Now, here's got some definitions. Okay. And again, I think you're probably familiar with a lot of them. You know, quadrilateral is just a four-sided polygon. Parallelogram, both pairs opposite sides are parallel. So you'd have this situation, right? Rectangle, I think you've dealt with rectangles for a long time. You know, notice how it's defined. A rectangle is a parallelogram with at least one right angle. Okay. So it has all the properties of a parallelogram plus some additional ones. A rhombus is a parallelogram in which at least two consecutive sides are congruent. So it has all the properties of a parallelogram and then some. Look at that other sheet that I showed you. A square is a very special quadrilateral. It's a parallelogram that's both a rhombus and a rectangle. It's got all kinds of properties. A kite in which is a quad in which two disjoint pairs of consecutive sides are congruent. So disjoint means like separate, distinct, you know. Here you got that set, you got that set. Whereas like in a rhombus, they're more interchangeable. You could say this is congruent to that, that's congruent to that. So you can't do that with the kite. Now, trapezoid, I'm going to talk about this one for a second. It says exactly one pair of opposite sides parallel. Okay? The parallel sides are called the bases of the trapezoid. So if you have both bases, sorry, if you have both pairs of opposite sides parallel, you don't have a trapezoid anymore. You then have a parallelogram. Okay, so the way our definition is that a trapezoid is exactly one pair of opposite sides parallel. Isosceles trapezoid, trapezoid with non-parallel sides, the legs are congruent. Okay, I'm not, you know, you're going to have to spend some more time with that previous document getting comfortable with all this. I do want to talk about this Venn diagram here for a moment. This whole thing is, these are all quadrilaterals, okay? You can try to do this on your own first, but, you know, this is going to be a p-gram, and then it doesn't matter what you put on which side, but one of these is going to be rectangle, the other one's going to be a rhombus, and then inside here is going to be a square. Square is very special. But what this means is that all rectangle, squares, and rhombi are parallelograms, right? They're all a subset of parallelograms. Square is a subset of everything in there. Over here we have, this is trapezoid, and this is an isosceles trapezoid, right? An isotrap. Notice how there's something missing from this Venn diagram, and that is kite. And the kite's weird. It's going to be kind of its own separate thing, but it does have some properties of parallelograms, so there might be some overlap in here, but it's strange. I'm just going to kind of write it as its own thing. All right, but there is some overlap. In other words, a square is a special kite. Okay, a rhombus is a special kite. You know, a kite with all four sides congruent. You know, that'd be a rhombus. But you see, it's, you know, not all kites are parallelograms, so that's why we can't really put it in here. We can't really put it in that parallelogram oval. But, you know, a rhombus is a special kite, a square is a special kite. So you have to spend some, you know, my recommendation with that previous document that I showed you earlier in the video, focus on the diagonals, how they relate to each other, how they intersect, the opposite angles, and also focus a little bit on kite, okay? Now, there's an extension here. There's a couple pages of stuff to practice on. I'd recommend doing it. I think it's good practice. I'll just do a couple of these. I'll post the solutions on Canvas. Just be careful when you look at the solutions on Canvas, because in the very last page is ordered differently. So you have to be careful with that. For example, this says a parallelogram is a rectangle. You know, that's not true. That's false. And you could replace it to make it true. A square, all squares are rectangles. Notice how the square was completely embedded within the rectangle oval. You know, all squares are rectangles, but not all rectangles are squares, okay? Parallelogram could be a rectangle, but doesn't have to be a rectangle. But a square has to be a rectangle. So this one was false, and we fixed it. The diagonals of a rectangle are congruent. That's true, okay? And you can go through the rest of this yourself and then take a look at the solutions on Canvas. Fill in each sentence with always, sometimes, never. You guys love that. A parallelogram is, well, that's always a polygon, right? For sure. A parallelogram is, it's not always a rectangle. It is sometimes a rectangle, okay? A rectangle is, that is what? A rectangle is sometimes a square. A quadrilateral, well, not all quadrilaterals are rhombus, so that's going to be sometimes. So you get the idea here, but this is good practice. The answer key that I'm going to post is in a different order, so please look at that. But, you know, I would take advantage of this, okay? And then spend some time knowing those properties.